Hello. So in this video, I'm going to show you how to perform a chi-square test for goodness of fit in Excel and the step-by-step process of doing it in Excel. So the example here is from your assignment. The question is like this: use the chi-square test for goodness of fit to test the hypothesis that the number of suicides reported for each year from 2007 to 2016 does not differ significantly from an equal number of suicides in each year, and use 0.05 significance level to test it. So what is the first process in conducting a goodness of fit test? Like any other hypothesis test, here also the first step is, of course, specify null and alternative hypothesis. So your null hypothesis here is there is no significant difference between the actual number of suicides reported in each year and the average number of suicides. And your alternative hypothesis is there is significant difference between the actual number of suicides reported in each year and the average number of suicides. So this is the number of suicides reported in each of these years starting from 2007 to 2016, and I have calculated the average number of suicides here, and that is, this each year farmers suicide is nothing but your observed value. This is nothing but your observed value, and what is your expected value here? Expected value is nothing but the average number of suicide, that is this value. So let us get this value to each of these cells. You can select this and click F4, enter, and you just drag it. So that will make you to get the average of number of suicide across these cells. So that is your expected value. Okay, so once you specified the null and alternative hypothesis, the next step is to calculate the chi-square test statistics, right? And this is the formula for that. Chi-square is equal to sum of observed minus expected whole square divided by expected value. So that is your test statistics formula. So now you got the observed value and you got the expected value. So let us calculate the observed minus expected value square. So that means this value minus this value, take the square. So that will give you this number. So we have for each year, this is the observed minus expected all square. So now we need to find out the deviation of this square from the expected value. So for that you need to divide this with the expected value. So you will get so now you have the deviation of observed minus expected all square value from the expected value in each, corresponding to each of this year. And if you take the sum of this, so that this is the sum of the squared deviation from expected value. Observed minus expected square, deviation from the expected value, and that is nothing but your chi-square test statistics, right? So now we have the chi-square test statistics. Okay, let's keep it as TS, test statistics. Okay, so you have been given with the level of significance as 0.05. So the next step is we need to go by identifying the critical value, right? So for that you need the information regarding the level of significance, and secondly the degrees of freedom, right? You also need the information on the degrees of freedom. So what is degrees of freedom? It is nothing but your number of categories minus 1, right? So assuming this observation, these are your categories. So you have how many categories? 10 categories minus 1 will give you 9. So 9 is your degrees of freedom, right? So now we need to find out the critical value. So you can get the critical value directly from the Excel. There is a formula for that. So before that, let me tell you one thing. This is specific to the chi-square goodness of fit test. So the chi-square goodness of fit test is always a right tail test. So remember that your chi-square goodness of fit test is always a right tail test. So that means you need to always go for finding out a right tail critical value. Okay, so the reason is we are bothered only about a large number of this squared deviation, right? This value, because a small number, a small value of this sum will basically, what it is telling you is there is no difference between observed and expected value, right? So larger this number, more the possibility that you doubt uh, you doubt your, I mean, null hypothesis, right? There is not significant difference between the actual number of suicides reported in each year and average number of suicide, or that is in your case. And in generalities, you basically doubt the fitness of the distribution of sample and population, right? So that's the reason it is your chi-square uh, test is always a right tail test. So let's find out the critical value correspond to degrees of freedom 9 and the level of significance 0.05. So the formula to find the chi-square critical value is chi-square inverse RT. Okay, chi-square dot inverse dot RT. RT stand for right tail test. So your probability is nothing but the level of significance, right? And the degrees of freedom is 9, right? So uh, this is your critical value. Okay, now you can also find out the estimated probability corresponding to your test statistics, right? The exact probability corresponding to this chi-square test statistics. So for that you need to use a different uh, I mean formula, that is chi-square dist RT, right tail. Okay, chi-square distribution right tail. So your X here is nothing but your test statistics, and degrees of freedom is of course 9. So it looks like it is I mean many zeros after the decimals. So um, that basically tell you nothing but it is highly significant. Okay, I mean, anyway, let me stick on let me tell you about the first one the major way of making decision about the null and alternative hypothesis. So I mean, decision about whether to reject the null hypothesis or to accept it. So the one way you can do it is based on the test statistics and chi-square critical value, right? I mean, if your test statistics is greater than the table value, you basically reject your null hypothesis. Here, what is the case? Here, your test statistics is 3035 and your table value is 16.92. So obviously, you reject your test statistics is greater than the table value, so you reject the null hypothesis. So you reject the null, that there is no significance difference between the actual number of suicides reported in each year and the average number of suicides. So that means there is significance difference. Okay, there is significance difference between the actual number of suicides reported in each year and the average number of suicide. So that is one way you can make a decision about whether to reject or accept the null hypothesis. The other way is uh, with respect to the estimated probability and the level of significance. If your estimated probability is less than the level of significance, you basically reject the null hypothesis. But here, what is the case? You reject your null hypothesis. Of course, here your estimated hypothesis, that is estimated probability is very less, right? 0.000, and your level of significance is 0.05. So that means your estimated probability is much lower than the level of significance value. Okay, so that was your uh, level of significance. So that means uh, so that also provide the same conclusion, that is you reject your null hypothesis, that there is no significance difference between the actual number of suicides reported in each year and average number of suicide. So that's all about the step-by-step process of calculating chi-square test for goodness of fit in Excel. Thank you.